Everybody got their notebooks ready? All right, let's break this down and solve our problems one at a time. So we have ship health right now as a UI element that we want to, that is being displayed. What's one other thing we probably want to have displayed in the user interface? Yeah, score, right? Points for destroying asteroids. Okay, so we need that one. And right now the ship does get destroyed if we go below our health threshold. We need a restart so that you can restart the game. And sort of along with that, we need a message for lose/restart. And we need to generate asteroids throughout the game. Right now we just have our asteroids that start at the beginning. We're going to need a brand new script for spawning our new asteroids. Did anybody write down before what the terminology is for creating a new thing? What's the code? What's that? Spawn. In the code, we'll list it as instantiate. That's the word, the code, the actual C# Unity word we use to make a new thing. So we need to instantiate new asteroids. How do we want to do it? Yeah. So if we spawn them outside of the screen, and the asteroids have the wraparound script on it, the wraparound script takes anything that's outside the boundaries and bumps it over to the opposite boundary. And so as long as we spawn them outside the screen, they should snap over to some other element and drift onto screen at that point, right? So we don't need to, we need to make sure they're outside a specific area. So when we're making a new script, we need to take inventory here of what spawn asteroids. What does this functionality need to do? So it needs to make new asteroids outside the screen. This is probably something that we need to provide, right? How big is the screen? Screen size. Pretty much in terms of Unity units, right? How far, this is how we did it in the wraparound script. And so we need to make sure that we're outside of our boundaries so that we're not appearing on the screen. This will also keep us from spawning an asteroid on top of the ship, which would also not be the best design here, right? Because it would just be unplayable. You wouldn't be able to avoid that if it's just appearing on top of the ship. The asteroids themselves take care of the wraparound. The initial velocity on the asteroid is pushing them in some direction. So that's already happening. How often should we make a new asteroid?
Should more asteroids be on the screen the higher your score gets? Should be
Yeah.
like if
that's a two-step process, right? So number one, we need a rate of asteroid creation. And then our bonus here is we could link to the score. But first we need a controllable variable so that we can control the rate at which new asteroids are made. Once we can do that, then we can go about the business of having that rate increase as the score increases. Okay, so let's do these first two jobs. We'll take it apart one at a time. Okay, so you guys write this down so someone remembers it over there, right? So our first thing is that we'll make a script, put it on a blank game object. That's going to be called Asteroid Spawner. And the job of that object will be to make new asteroids, right? Again, don't go for the big bang here. We're going to try to do one thing, check, see if that thing works, then move forward and do the next thing. And so let's make a new C# script. This is it. Here we are at Asteroid Spawner. Just like with the fire laser one, this essentially needs to have an input of the asteroid prefab, right? Because we're going to instantiate something. The thing we're going to instantiate is the asteroid. And so that, if you look at the laser one, it's a public game object. Using the public will mean that it'll show up in the script controls so that in the editor we'll be able to drag in the prefab that we want to spawn. And we'll call this asteroid. That's how we'll refer to it in the script. Let's look at and can someone keep an eye on the chat there? Let's look at the fire laser script so we have that to compare with, right? And so here, which line actually makes a new projectile or laser? Yeah, line 19. Remember, instantiate is make a new thing. This is what thing do I want to make, and then where and rotation. So we can use this as a good starting point. Bring this back over here. We're not going to make laser prefab. Up here we've asked for it and we named it. We're going to call it asteroid. And let's keep some consistency here. So instead of calling it asteroid, call it asteroid prefab so that our nomenclature remains consistent as far as, tool design here. And so I'm going to copy that and paste it down here. And let's test it. Here, I'm going to make a new 3D object, just empty. Asteroid Spawn spawner. And I'm going to move it just over to the side a little bit so it's not directly on top of my ship right now. And let's provide our asteroid spawner script. And we see that it does, because I labeled that variable public, we get this field here that allows us to fill it in. And so I'm going to provide my asteroid prefab. Let's save and test it out. Okay, well, we have successfully made asteroids. Mission accomplished. I think we're done here. I wish I could turn the camera over to Caitlin, whose jaw has literally hit the floor over the flooding of space with asteroids here.
That may be a little hard.
We need to chill this out somehow, right? Our game went from kind of like kid style to unplayable. Let's examine what's going on here. How often are new asteroids made? Let me type a comment here while you guys are thinking about it. This line of code, instantiate, is inside which function? We have two main functions that we know about. It's in update. And feel free to reference your notes. How often does update run? Every frame, right? Which is kind of as fast as possible / 60 frames a second, right? So we're creating 60 new asteroids every second. We need to slow this down somehow, right? One way to approach this, Unity has a mechanism for handling this. And that method is called invoke repeating. This allows me to I'm not going to use invoke repeating actually, because invoke repeating does a good job of repeating something, but the nature of it may make it more difficult to change the rate at which we repeat later on. And so if you just use invoke, it asks for a method name and a time for how long until it happens. And so we've got invoke here. A method name, and so there's void start and void update. The thing we haven't done that you can do is you can write your own functions. Void whatever. And in this case, let's name it void create asteroid. We'll say spawn asteroid. Allow me to fight autocorrect for 10 minutes. Spawn asteroid. There we go. And we have to use the same format. So use that parentheses, parentheses, and then two curly brackets, right? Curly brackets are the way that you communicate functions or methods in C#. And this is essentially a verb. The stuff that goes in here is going to happen. And so up here, at the very beginning, we need to essentially call this method. And so we need to refer to it by name here, spawn asteroid. You need to be careful typing the name. I'm going to hand off the script to you, but when you make up your own methods, all of that auto-checking, how we get that red underline if I type some gobbledygook the computer doesn't understand? Well, once you start making up your own stuff, then that, if you're referring to that level of checking doesn't maintain. Anyways, 5F, right? And well, let's make it smaller. Let's say 1F. right? So because it says, what do we want to do? We'll do this thing, and we'll do it after a second. And so here, I'm going to take this instantiate asteroid and cut and paste into our function. And so now, what should happen is when the game starts, it'll call invoke spawn asteroid after 1 second, right? This essentially, it'll start a clock, and after 1 second, it'll do whatever we put in this function down here. And let's test that out. Cool. That worked, right? After 1 second, we made 1 asteroid. Super. We need to keep doing it. We can do that by sort of recursively referring to that function. So this line of code here that called that function, in the function that we called, I could then call it again. So make another asteroid. And so this should give us a loop where every second we do this, call the same thing, go back up, wait a second, and then do the thing again. Let's see if that works. Good. So we're making an asteroid every second. So far, so good. That's great. But we want to be able to control the speed at which new asteroids are made, right? And so this number right here, which is how long we wait until the new one gets made, this is probably something we want to control, right? And so we want to make this a public variable up here. And so f, when you see an f after a number, what does that mean? What's that? Float. And what does that mean? Decimal point number, right? And so when we make a new public variable, we need to refer to it as a float, not an int. And we need to call it asteroid rate. And in cases like this, you want to give it a starting value, right? And so maybe at the beginning here, we'll give it a 5f. You can always change this later. And so now this asteroid rate, since it's a public variable, we'll be able to access it from other scripts, eventually linking it to our score, right? And so as the game goes on, do we want this number to slowly get bigger or smaller? Right, because it's the amount of time in between asteroids, right? So as the game goes on, if we want more difficulty, the time between spawns should shrink, right? We're not there yet. We need to replace our current rate with our variable, right? And so here, instead of 1f, we should have asteroid rate. And same thing here. Let's give that a shot. Let it compile. We should get a second control up here. And now if I hit play, there we go. Cool, we're getting an asteroid every 5 seconds. If I change it to 1, now we're at 1 second. If I change it to 0.1, we're back where we started. Cool, so that works, right? If we can find a way to link this number inversely to our score, we'll have some dynamic difficulty throughout the game. Everybody with me there? The only downside I see to this is that there's not a easy way to interrupt the loop. So if you're taking a step down, this number technically doesn't update until the next one, right? But I don't think it's going to be a problem, right? We're going to be incrementally, we don't want to go from no asteroids to asteroid spam. So these incremental steps should be fine in terms of difficulty. Okay, what other problem do we need to solve with this script? We've got them made, and according to when. What's that? Outside the screen. Yeah, right now they all, where are they getting made? Just right here where the object is, right? Where the blank asteroid spawner is. And if you look at the script, why is that? Because of this line. Transform position. This, when there's nothing before transform, this refers to the game object that the script is on. Right, so whatever the current position of this object is, fill in that position right here. And same thing with the rotation. So we need to change this business here. And let's look at, we can probably derive some guidance from our wraparound script. And here we're taking the transform position and we're changing this to that wraparound area. And we want them outside the screen, but we don't want them at the same spot outside the screen, right? We want them to be sort of random. But let's break it down one at a time. Let's just get them to move outside or be located outside the screen. And so here in the asteroid spawner, we'll come back to here. And the way that we refer to, how do you control where an object is? You have to control it's what, and what. It's X, Y, Z. When you put those three things together, what I would write down in my notes is that it's called a vector 3. When you're just working in 2D and you just have X and Y, it's called a vector 2. The vector 3 is a way to package all those things up together. Vector 3, we'll call this spawn position for now. And now, instead of instantiating wherever the object is, let's have it instantiate at spawn position. And now you see that when I make a public vector 3, it gives me this. It allows me to enter, an X, Y, and Z parameter. And so we can test our theory there that as long as we spawn them outside, that they should automatically wrap around. And so if I look at the edge of the screen here, how big is this? Right, so Y maybe like 25 and X like 40. Okay, so let's say 40 and 25. And let's see how that works. I'm going to make it a little faster so we can get quicker results. getting a little drifting there. I think a few things we want to do to our asteroids are wrap around. Probably want to give ourselves a little bit more room outside of the screen. So maybe make this like 38. Again, these are my numbers. Your camera zoom might be different. And 24. And then also our initial velocity seems like it could be, the slow is too slow. So maybe I'll make it 300 or something. So that less chance of them like just being spawned on top of each other. Cool. I think maybe just a little bit more room there. Let's say 40 and 25. Okay, that works. However, we want to not have them all coming from the same direction. I think we could do this trying to think what the simplest way to do this would be. We could have 4 positions and have it randomly pick between those 4 positions every time it makes an asteroid. If we made in the corners between that and all the other ones flying around, I think that might get the job done. So let's do that. In this case, we'll need a public float x position. Ours is going to be 38 based on my current thing, but again, I'm making a public variable, so it's adjustable. And we'll make another one public float y position. Our z will just be 0. And so here, we need to do some randomization. Those 4 positions we need 4 different ones here. We have our x min and y max, y min, x min, x max, y min, x max, y max. We need to store this position. And we need to do some randomization, right? I like to do these things kind of based on 100. It sort of makes them easy to visualize or think about, right? And so I'm going to make a new float. Call this random choice. And I'm going to give it a random dot range of 0 to 100. And then we will make a choice based on random choice. And so the first one, for instance, would be if random choice is less than 25. Do this. If random choice is less than 25, we'll make the new position, which is spawn position, equal to x position y position. These are the values that are up there at the top. And 0. If random choice is greater than 25, and then this is the sign for and, two of those lines, random choice is less than 50, we can grab this, make sure I get my capitalization correct. And so here, that's max, max. Now we'll go min. How do I make it a min? Just by putting a negative in front of this variable. That moves it over to the other side of the screen. That's our one of the other corners. So max, max, min, max, max, min, min, min. The four corners. Now that we have the pattern, you see how this is going to work. Now if random choice is greater than 50 and less than 75, spawn position equals max, min. And if random choice is greater than 75, then we'll go to min, min. So positive, positive, negative, positive, positive, negative, negative, negative. That gives me my four corners, right? We did this in 184. 0, 0, 1920, 0, 1080, 0, 1920 by 1080. Same concept. But the numbers that we're actually using are numbers that we put up here. We don't want this to be public anymore, this spawn position, because we're referencing it down here. And let's put a note up here. This is pick a random corner. Let's see how that goes. It's some sort of error. So if I double click, it should take me to the line. So this is currently unassigned. We'll give it a default value. Do I need a what?
An F after the 25, 50, and 75, and the other ifs.
Oh. I think so. I'm not sure if that's why it's not working or not. Let's give it a shot. And come back here. Save. Okay, that's better. Cool. Right? We are getting it sort of randomly picking between the positions. Moving the wraparound coordinates further out, the way things are moving, you're going to get things going back and forth across that barrier. But if we move the barrier further out beyond the edge of the screen, we shouldn't be able to see that blinking. But that allows us to do that. So that ended up being a lot of code for something fairly simple. Right? What did we do? Okay, so let's make it just a touch simpler, I think a little less. So the 100, we're not going to change the functionality at all, but if I do this, if I come in here and instead of saying 0 to 100, I say 0 to 0, 1, 2, 3. If I say 0 to 3 and I don't put an F afterwards, right? If I use an int in a random.range instead of a float, instead of giving me all the decimal points between 0 and 3, it'll just pick 0, 1, 2, or 3, which is 4 choices, right? So that's the one that gets people when they start counting in code is 0 is the first thing, right? And so we should be able to get the same results if we say random choice equals 0, which I think makes this 4-way coin flip a little bit clearer. Equal to 1. When you're testing if something is equal, it's actually 2 equal signs. This is another part of writing conditionals. And then we can do the same thing here. If random choice is equal to 2, and if random choice is equal to 3. We should get the same result. Let's test it. I think that's a little clearer to read, right? So we pick a random number between 0 and 3. If it's 0, if it's 1, if it's 2, if it's 3. Same probabilistic outcome, I think, as far as I can project, but let's look. Yep. We got all 4 corners happening eventually. Cool. A little simpler. Math. All right, this one's good. We're making scripts. We we have spawned asteroids. We are controlling where those asteroids go. Asteroid variation. I think we should control this in a very direct way. So by direct way, I mean I want you guys to make variations of asteroids. So maybe there's some big asteroids and there's some small asteroids. And so here, let's go into prefabs. Here, I'll take another asteroid here. This one, I'll make it darker. And I'll make it smaller, maybe 0.2. And maybe that's too small. 0.3. And this one, I'm going to change to asteroid small, drag this down, and I'll say I want to make a new prefab out of this. There we go. So now we have asteroid spawner, but it only has one slot for the prefab that it makes, right? And it'd be great if this was expandable, like it could pick between any number of asteroids, right? Anytime we need to essentially give it a, not just one asteroid, but like a set of asteroids. Anytime a bunch of things in the computer is an array. Think of an array. These are all different things: an array, a list, a dictionary. They're all different ways of creating like indexed spreadsheets of stuff. Ours is going to be really simple. It's really just like a list of objects, right? Which you could refer to by index. So we can do that like so. If we go to Asteroid Spawner, instead of a public game object, we are going to say the brackets for arrays are square brackets, right? So curly brackets, methods, like a verb, they do something. Square brackets, arrays, a list of stuff. The stuff can be anything. It could be a list of numbers, could be a list of game objects, could be a list of anything. And I'm going to change the name here from prefab to prefabs. Now, we need to randomly select amongst our list. Randomly select a prefab. And it has to be an int. When you have a list, there's no floats, right? You're either the first one or the second one. There's no halfway between the things in the list. So this will be prefab equals random dot range between 0. And here we have a very convenient thing, asteroid prefabs dot length. And so no matter how many prefabs we have, the maximum random number will always be tied to the length of the list, which is super handy. And now we can put that in here. And we referred to it by asteroid prefabs. We'll call this prefab number. That makes more sense. And so you have to put a square bracket and call it prefab number. Right, so now asteroid prefabs is a list, and then inside the square brackets, every time you refer to it, if you want to pull something out of that list, you put the index inside square brackets there. If I come back to my asteroid spawner, now check this out. Asteroid prefabs has this little arrow. This is important. And so now I can say, okay, I want 2 things in my list. So I come over here and press 2. And when I expand, now I have 2 slots. This is dynamic. It's a nice part of the interface design. If I want to make 5 different things to shoot, I just put 5 up here, and now I can provide all 5 of them, and the script will randomly choose between all 5. Let's go with 2 and test our thing. And so now back to prefabs. We'll bring in asteroid 1 and asteroid small and save, and let's see. Cool. So now we're randomly choosing between the big one and the small one. And all you have to do, right? So now, yeah, you can make maybe a really big one, and you know, now it's not a matter of manipulating the code. It's just a matter of creating a list of prefabs. You control the size by varying the prefab sizes and just providing them all here. Does that make sense for everybody? And what was the name called? That is called an array. Always the square brackets, right? And so, you know, asteroid list. I should call it asteroid array because a list is actually technically different. And then in here, you would put whatever number you want from the list. Do I want the first thing in the list? The first thing in the list is 0, not 1, 0. Cool. So that allows us to have variation. While I was doing that, the other thing I was thinking about was in my ship, I have my propulsion particle system. And so now, if I do that, the small asteroid should be like on fire. Getting cooler, right? I mean, if you have the option to set something on fire in the game, the answer is always yes. Right. Can we put that explosion over top? In the draw renderer sorting mode, sorting layer. Am I just not seeing sorting layer? There should be a sorting layer. Oh yeah, sorting layer here. New layer. There it goes. And so now that layer is on top of the asteroid. Maybe these are a little bit bigger. Let's label this space fire. And maybe not quite that big. What is the key parameter right here on the screen that makes the explosion trail behind the asteroid? Exactly. Simulation space world, right? That allows us to, you know, when a particle is spawned into the world, it no longer cares about where the parent is. It now exists. If the parent rotates, it doesn't affect the child. If it's local, then everything is like stuck to the parent. Cool. So now you can have a lot of fun, right? We can make big asteroids, small asteroids, asteroids on fire, asteroids with like weird glowy stuff, all sorts of things, right? Really vary things up here. That is all much better. Okay, so we solved our problem of asteroids spawning. We need to get some score happening here. And in this case, excuse me, we need which script is actually in charge of destroying things when they're hit by a laser? Destroy on trigger, right? And so if we look at that one, this script goes on our asteroid, and down here, this bunch of code runs when it makes contact with a laser. And then this stuff happens. What happens? If we have a destroy effect, we instantiate the destroy effect. That gives us our explosions and our explosion sound. And then we destroy this game object. And so in this code here, this is when we would accumulate score, right? And so this piece of code here is where we would need to count the score. The problem is we couldn't just sort of have a score variable and add to it here, because this game object gets destroyed. This code goes on the asteroid itself, right? And this sort of reveals a whole other issue about how you structure, your game code. In Unity, we split things up into these tiny bits, because I think it's easier for people to conceptualize when it just does that one job versus having everything in one big piece of code where I think it's less applicable. Anyways, here is where we would need to store our score. So ultimately our score is going displayed on the canvas here. So let's put some things in place for that. And then a separate one for the actual number. Make sure that this is justified right. Put this up here. So we need some way to store the number on this and have it incremented or increased every time we destroy something, right? So let's do that. Let's go back to our destroy on trigger script, and I'm going to go ahead and say our scoring can just be ints, because come on, like, seriously, int. We need to give this score value. How many points is this asteroid worth, right? By making this a public variable, you could have bigger asteroids worth less, more. I mean, you could make that decision. Anyways, let's say 10. But it'll be a public variable, so you can change it. And here, we need to connect it to the game object that does the scoring, that displays the score. We'll call it score number display. Cool. Okay, and so now down here, I've got to do one of these things. If score display is not equal to null, right? This allows the code not to break if you haven't filled this in yet. We have to do a couple things here to make sure we can use the Text Mesh Pro objects. Remember, these up here define what dictionaries we're using, right? So when you use something that's slightly expanding the functionality, you need that there. Just for the sake of time here, I'm going to make a quick change. We're going to need one more script here. We're going to call it Scorekeeper. It's going to be pretty simple. We have a starting score. All right, that was a little bit of boilerplate there, but now we're back to here. And so in here is where we would actually add to it. Scorekeeper. All right. This part right here is where the magic happens, right? So if we've provided that value, then in here, it's going to look at where we're storing the actual score. And then this is the line that actually increases the score. Increase score. If you destroy one of these things, the score, which is stored in the variable starting score, should now become equal to whatever that number was. This is the same thing, plus the score value, however much that particular value is worth. And so let's do that. On our score number here, we need to provide that scorekeeper script, which should be fairly simple. There it is, right? And so we just give it, no, not two of them, just one. And then we also, on our asteroids, right? So you're going to need to replace your destroy on trigger with the new one. But it does have a default value, but we need to provide the game object that we're going to use to display the score, which is this one. Actually, let's make it even easier. We need to get the object with a tag. I forget what this one is off the top of my head. Tag get object. There we go. Find game objects with tag. let's see.
Looks like there was an extra C in scorekeeper in the script.
Ah, good eye, Kendall. So let's, we'll put this in here, right? So instead of dragging in the game object with the scorekeeper, we'll identify it via the tag. However, doing this, what I just did, is dangerous for the said reasons, right? I spelled it wrong, didn't see I spelled it wrong, blah, 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 blah. So instead of me hard coding a name in here, I'm going to have you, like I did with the name enemy, provide that. And so we'll say public string score tag name score keeper tag name equals score keeper, right? This way you have control over this, right? And so now instead of hard coding in the string, right? A string is any name, right? We're referring to something by name. We'll use the variable and you will have access to the name. All right, and so this tag this tag name here needs to match whatever tag I put on here, which I believe is the same, capital K, and then just check our asteroid, capital K. I think we should have it. Do you think there's enough particles in the game? So there's a little bit of boilerplate as far as connecting all of that stuff. But what you're going to need to do is just sub out the destroy on trigger. I'll update that here in a second when we take a break. And then creating this was a matter of, I made two objects. One for the word score. It's just a UI piece of tag that says score. That's it. The other one displays the number. Now remember, this is like the other game in that the number that you see before you press play is going to be whatever you type into the text box, right? However, that has no bearing on what happens once the game goes into play mode. You'll start at this score, and then whatever value you give your asteroids, and since we made it a variable, they can have varying values, is what it will increment to as you keep playing. This gets a little more complicated there that I wanted to get into, in that we have a prefab referencing a game object. Doing the opposite, having a game object reference a prefab, is not a problem. You can just drag your prefab into the junk over here, right? That's what we did in our spawner. The other way around, if you think about it, is structurally different. These things are not in the game. right? When they're it's just data. They're not in the functionality of the game. And so the change I needed to make here is that instead of dragging the game object in there, because you can't drag the game object into the prefab, is that when a new asteroid is made, this code runs. And essentially when a new asteroid is made, it looks through the game and finds the scorekeeper. It searches through all the objects to find the one that says scorekeeper. That way it has it saved so that when it gets destroyed, it can add to the score. Right? So the structure of what you're doing there is a little bit different. There's some different ways to do it, but that works. Did I delete something? I think we're okay. And let's make one more here for right now, a quick way to replay. Let's go back to our documentation. How many of you guys have looked in the documentation since we started the process here with this game? The important thing to remember is that there's two halves, right? This is like using Unity, and this is the documentation for writing any scripts, right? So it's important to realize which half of the documentation you're looking at. So it'd be great to just restart without having to replay the game. And let's just link that to the letter R right now. So if I look to reload scene, let me look. I think I have this one from a previous semester where I did that. How do we put in the starting splash screen? Like if we want to, what's the name of this game? Seems like really lazy on your part. What's the name of mine with my theme? You guys feeling particularly uncreative today, or? Farina asteroids sounds worse than asteroids. Space Station Defender. all of the stuff we did before here applies. I'm just gonna put this in here for now, but I'm gonna find some better font settings here, or perhaps just design my own thing in an image and bring that in. But here, we have our title. I can create an animation for the title. Right now this will automatically play at the beginning of the game, but if I come back to my animations, title animation, turn off loop, now it's out of the way to play, just like we did in the other one. Let me update those two scripts on the repository list of stuff, and then we can go from there. Oh. This thing is exactly at the height of my knee. There we go. Any questions on the chat?
Just title videos, like Casey's Independence Day.
That's not bad. That's not bad.
Or
Who was that?
that was Nikki. She also said Farina Geddon.
All right, well, Nikki is just frankly out creating you guys today. Farina Geddon, not bad, not bad. How many of you guys have seen the original Independence Day? Did anyone see the second one, not the first one? Okay, well, at least that hasn't happened. No, we need the script to link the spawner to the score. Let me post these other ones first.
Professor, did you see the chat? Nikki asked if there's still time for a Tesla triangle electricity thing.
Yeah, hold on. I'll do that in a sec. So Nikki, the electricity is like an effect that goes on top of the ship, right? So it's small. So I posted those new scripts there. Nikki had a good question. I'll try and do this one real quick. So she wants to have, what I understand, like her ship has 3. I don't know if we can see it on her thing. I assume it's here, here, and here. And Nikki has these things on her ship, and she wants them to look like they're attached by lightning. And in this instance, because it's small, and because it's going to be there all the time, using the particle system to go from point to point here is going to be kind of overkill. And so in this case, I think using a sprite sheet is going to be a better call. So here in we need it doesn't need to be very big. So we'll say maybe 200 by 400, 12 frames per second, maybe just like 3 seconds. I don't know. Let's see how that goes. I made a new solid. I'm grabbing advanced lightning. The lightning has 2 spots on it that you can connect here. And to connect them, I think I did 2-way strike. And most of the stuff is kind of self-explanatory. You can change the core and the glow and mess with the colors. this conductivity, they should really name it that something else, but this sort of animates it. And so I'm going to keyframe and keyframe. And so I've got lightning here, right? And I'm going to composition add to render queue. And we want it to be a PNG sequence. Critically, we want it to have alpha channels. So we got to say alpha channels. Okay. Let's put it in a folder. And when you're outputting an image sequence, don't get rid of this. That has the number in it. So this will be lightning. And we will render that. Hold your ears. This sound's going to be loud. Never mind. All right. Cool. Usually After Effects just gives you that really loud render sound. Awesome. Now let's bring that into Unity. I'll go to bring in the whole folder. And where's lightning? Here's all my frames. If we grab all of them, sprite, apply. Does that clean up our alpha channels? It does. That looks way better. And so now, I believe if we grab all of them, and if we just do this, drag it up here like this, it'll take all of those frames and sequence them. And so this will be lightning animation. We need to put it in the animations folder. And now if I look at this, here it is right here. Hit play. I've got that. And so now, I could use this as a design element on my ship, right? So turn this thing off for now. Right on my ship, like if I wanted to take this lightning here, bring it up underneath my ship, put it over here, and maybe it connects these things on my ship. I could sort of rotate it and sort of scale it where it would need into position. If I wanted to chill this out. If I didn't render color in it, then I would be able to control the color here a little bit better, but there we go, like that. Cool. And now my space station is getting weirder and weirder. And so then, Nikki, when you duplicate them, you could either make 3 different ones, or just duplicate this one and then change the speed so that they, animate slightly differently, or you could make 3 different ones or whatever. That's going to be a easier, because it's so small, there's no reason to be generating a whole, and I've already liberally used particles in mine, so just adding more particles on top. This will be a little bit lighter weight. Also, I didn't make it huge, right? So I didn't make it high def. I knew it was going to be small in the game. I don't need to nail the size, but I made it like 200 pixels by 400 pixels, right? So it's not super heavy lift. This all kind of got out of hand. I originally was going as sort of NASA inspired, but we've drifted. Last time I've seen pictures of the ISS, it didn't look like this. But that's what happens. So this technique we could use for any animation that we would want to get out of After Effects. Keeping it short, right? This is 12 frames per second at this speed here. So it's only about, I don't know, how many frames did I end up with here? 38. It's not a huge number, right? If you do this and there's like 7,000 frames, like that's probably not a great idea. And I believe when you build now, Unity actually, if you use a sprite sheet like this, or not, if you use a image sequence, during the build process, it's going to take your image sequence and build a flipbook out of it so that it's more performant. It does all of that behind the scenes. You don't even need, as far as I'm aware, you do not need to tell it to do that. And so that works pretty well here. Right, so, I mean, the red there looked really good. We're going to have to make a Star Wars Sith game just to use that. Yeah, just like NASA. All right. You see I put those other scripts up there? And then I also added one more. I think I put it up there. Restart scene. Fairly self-explanatory. So I made a new game object, called it restart. I put restart scene on it, and it has one parameter. What key do you want to use to restart the scene? That. You could put it in your instructions once you lose. That oh, I took out the title text, which is why we're not seeing that. Title, turn that back on. There we go. Right, so I press R and the game restarts. All right, let's check the score, make sure that actually works. Yep, cool. I think I'm renaming my name. And I'm grabbing the Bon Jovi song to use as my soundtrack. So, Nikki asked about the electricity question, but yeah, a lot of people could probably use that. You could make an electrically charged asteroid. Why not? What's that? Sure, sure. Yeah, anything that all of your After Effects skills, right? Anything you can do now in After Effects, you can put in there as part of it. Let me make sure I put that one on the script list. I'm going to see if I can find a Muzak version of that. Maybe it doesn't exist yet. The Muzak version of Blaze of Glory. Looks like I have my weekend cut out for me. What about electrically charged space llamas? You mentioned it, Nikki. You have set expectations. Monday, you know what we're going to be looking for.
It's bigger spaceship a llama. And they just have lasers. I mean,
Like space llama?
I guess so. Just put a little helmet on her. Kind of shoot laser.
Yeah, I mean, Nikki really shamed everybody today in terms of the naming. Jose came in with Casey's Asteroids. Jeez.
Nikki said, why not Aerosmith?
I mean, I went with the Blaze of Glory song because it's like there's like fire and lasers everywhere. I'm trying to think of the equivalent Aerosmith song here. I mean, I guess it's the one from Armageddon. I miss you, but I don't want to miss a thing. Whatever the hell the name of that song is. Yeah, I don't want to miss a thing. There's got to be a music version of that. That's a little more popular than Blaze of Glory, I would think. Yeah, that one would be good, right? It does have the asteroid connection there.
She said sad music for when your ship loses.
All right, so tomorrow I'll try and post all the requirements for Monday, essentially everything we've done this week, right? Putting music in the game, everyone knows how to do that now, right? So they've got some kind of soundtrack in there. You got your explosions, you got your laser sounds or whatever sounds, you got your llama sounds. I have to look. Llama has one M, right? The animal?
I think it's ILAMA.
What?
Llama has 2 L's. LL.
Okay. Yeah. Dalai Lama has one L, right? I don't know. It's a free sound effects library. You get what you pay for, I guess. Yeah. As soon as I think of it, I'm hearing a goat sound. I mean, I guess I've seen llamas before. What's the other animal that looks just like llama?
Alpaca.
Right. I mean, I can't really. Does everyone know how to differentiate between alpacas and llamas?
I think that's
One of them spits more.
yeah, I think
Okay.
all I know. I think alpacas tend to.
I'm into that.
That was clearly a person.
That was a person. It wasn't even one.
That was
Granted,
clearly
it's
a
pretty hard
human.
to get a 1 minute sound studio, so I doubt there's
That'd be pretty good. Every time you shoot your laser, Star Farina? I don't know, Frank. You guys just aren't playing the same game Nikki's playing here.
That's the best name so far.
You guys know which song I'm talking about, right? I'm going to stop the stream so I can play it and not get pulled off of YouTube for playing Bon Jovi, which, come on.
Copyright.